Hi guys, welcome back to our channel. Today I'm going to talk about Seaborn, which is the library built on top of Matplotlib, and this library is used to have very attractive visualizations and very smooth graphs is possible by using this library, and it's very user friendly. So we'll have a tutorial on this today. So how to do the installation? So if you don't have it, the basically you can do the installation by using pip. So pip install Seaborn, and if you are having Anaconda installed, then no need of doing any installations. It's already available with Anaconda. So at first I would like to import the libraries which are required for me. So usually you can also do this at the later stage, but normally so we'll import the libraries at the first. So importing NumPy as NP to have a multi-dimensional array, and I'm using pandas to create a data frame, and this is the library how you install it. That is import Seaborn as SNS. So SNS is alias, just like importing pandas as PD is alias, short name. And we are also doing import of matplotlib on top of matplotlib. You can also do the visualization using Seaborn. And sometimes some future warnings comes or some unnecessary warnings comes, and if you want to filter out, then you have to import warnings, then warnings dot filter warnings ignore. So once these libraries are imported, this library also comes with predefined data sets. So if you just want to know what are the predefined data sets available with this library, then we can have a print. So print sns dot get dataset names. So this is going to list out the set of data sets available with this library. So you can have a look anagrams, Anscombe attention. So the famous dataset for available with this library are iris. I hope you have the fundamental knowledge on iris, and you exercise data is that, tips, and titanic. So these are the popular data sets. So we'll use some of the data sets to plot various kinds of graphs. So at first I'm creating a data frame by loading the data set car crashes and then displaying the header part of the data. So car crash df, which is user defined name, dot head means by default it is going to display first 5 rows. So these are the first 5 rows. So this is continuation. So the column names are total, speeding, alcohol, not distracted, no previous, insurance premiums, a premium, insurance losses, and then abbreviation for this particular incident. So this is the data frame. On top of this, we would like to plot different kinds of graphs. So the first category of graph is distribution plots. So the main use of distribution plots are uh, to show the distribution of the data. So within this, the first type of graph is distribution plot. So distribution plots are used for univariate analysis. It means you can explore single variable. So univariate distribution provides us the distribution for only one variable. So sns dot dist plot. So this is the function dist plot of, you need to specify the column name from the data frame. So from crash df, from this data frame, I just want to know the distribution of this column, not distracted. And kd is equals to true, means kd stands for kernel density estimation, which is equals to true. And number of bins I have mentioned as 25. So you are going to have totally 25 bars. So this is the distribution plot showing how the values of this column are distributed. So the majority of the data are having the values in the range of 5 to 20, and this is the line graph, or that means KDE, kernel density estimation. So on x-axis you are having the values of for the column not distracted, on y-axis you are having the density. So remember, it is used for single variable distribution. Next, another graph which falls under this category is a joint plot. It is used to compare two distribution, and you can also have a scatter plot by default. So look at my graph here. So SNS dot joint plot. On x-axis I'm taking alcohol from the same data set, and y-axis value is speeding, and this is data frame name. Kind equals to REZ, means regression plot. You can see on x-axis you have alcohol, on y-axis speeding. The relationship between these two variables is positive. That means if the person is alcoholic, then speeding value will increase. So there is a positive relation, and you can also see that no histogram here. So how the values are distributed for alcohol, and this represents the values of speeding. And you can also have the another variation, that is x is equals to alcohol and y is speeding, and kind equals to KDE. So KD, kernel density estimation plot. So this shows the density for these two variables, having the relationship between these two variables, and you have a density plot. This one, this is for x-axis attribute, and this is for y-axis attribute, and these are the density values. And also remember, it is used for no bivariate analysis, means you are exploring two variables. And one more variation is kind equals to scatter plot, means you are showing the relationship between these two graphs, and the values are plotted as a scatter plot. You see, this is how it looks like, as a scattering the values of these two variables, alcohol and speeding. So these are the three variations in the distribution joint plot. The first one we have used regression, so having a regression line here and plot. Then next one is a kernel density estimation. The third one is having a scatter plot. So remember, it is used for bivariate analysis. Next, if you just want to have a kernel density estimation plot, then SNS dot, this is the method, KD plot. Next, you need to specify the column on which you are having this. So this will give us the distribution of the values. So single variable, this graph is used for univariate analysis. So as you see, the majority of the values are in the range of 0 to 2 to 8. So you can see the density value on y-axis. The another graph is a paired plot. So it is used to show the relationship across the entire data set, entire data frame. By default, it assumes the numerical values. It only plots the numerical values. So SNS dot paired plot of crash DF, as multiple variables are plotted on the graph. So it will take couple of seconds to see the output. So it is doing the processing in the background. So if you have wait for a couple of seconds, you can have the graph. So all these are numerical variables. So total, speeding, alcohol, not distracted, no previous insurance premium and insurance losses. So if the variable is same, then you can simply have a histogram. For example, this is insurance losses on x-axis, and y-axis also the same. So simply you have a histogram. If the values are different, you can see this is total and this one is insurance losses. The relationship between these two variables is shown as a scatter plot. And I'm creating another data frame for the data set, that is tips data set, then displaying the header part of this. So in this data set, you can see these variables: total bill, tip value, then gender, male or female, then smoker, yes or no, and day, so which day of the week, and then time, and then size. So you can have the size, and you can see the total bill also. So let's explore this data set. So I'm having a pair plot. So first we are mentioning the data set name, data frame name, and then comparing with gender here, and palette, you are specifying the color palette. So there are different color palettes available. For more information, you can refer the documentation of Seaborn. So this will give us the relationship between all the variables comparing with the gender. So you can also have a legend here, so male, female, and compare this with other attributes. For example, total bill. So this is a relationship, total bill and size, tip size. So this is a graph. So total bill, right? Total bill with if it is same, then you can have a simply distribution plot here for male and female. So for male, blue color is used. For orange, this orange is used for female. So this is the paired plot of all variables or numerical variables compared with gender. Next, for more information, you can also take a help so that you can know what are the different parameters used with this function, and you can do that. So SNS dot paired plot of question mark. So these are all the parameters, and if you scroll down, so you can see the variable no, purpose, and then examples also you can see. The next plot is a Rook plot. So this plot is used for single attribute, that means univariate analysis. So it plot a single column of data points in an array as sticks. So you can have vertical sticks. For example, if you want to have a Rook plot on the column that is tips, then it displays. You can have a vertical line sticks as the lines on x-axis, and then I'm applying the Rook plot on another attribute, that is total bill. So this is the total bill values. Whenever you are doing data visualization, you can also use different styles. So for example, SNS.set style is equals to doc. So these are the different types: white, dog grid, white grid, dog, ticks. So these are the stylings, and you can also specify the paper. So set context paper, specifying the font scale 1.4 here, and I'm having a joint plot between the variables alcohol and speeding, and this is the data frame name, and kind is equals to regression plot. On top of this, you are also adding a dispine. So you can specify the attribute for this left spine you want to have or not. If you want to have, then you can specify true, otherwise false. So left is false, bottom is false. You want to have right, so that's why true, top, true. So we are going to have spines right side and also top side. So this is top and this is right. So for left and bottom we mentioned false, means we don't want to see. If you specify true, then you can also see them. So on x-axis alcohol, and y-axis is speeding, as we have seen it before. So relationship is positive. That means positive means if alcohol values increases, then speeding will also increase. The next category of the plot is categorical plots. So when you have a categorical variable, so how to explore that? So the first plot which comes under the categorical plot is bar plot. So it shows the relationship between the variable, and one of the value is categorical and another variable can be a numerical. So here I'm setting the styles to ticks, and then having a relationship between the gender and total bill. This is the data frame name, and estimator is equals to np dot median. So the median value is found and then filled on the missing data. So you can see gender on x-axis, y-axis is total bill. So if you look at this graph, so who has paid more bill, male or female? So by looking at the graph, so male are having the larger value, that is more than 17.5. So male have paid more bill than female. Then another plot which falls under the category is count plots. So a count plot means it will show you the frequency of the values. So for example, data frame name dot, this is column name, so gender, sex, dot value count, means how many males and how many females are there. So we have two unique values in the data frame for this column. So males are 157 and females are 87, and you can see the name of the attribute is sex and the data type is integer 64-bit. So the same can be done by using a count plot. So we are showing the value count by using the plot. So here is the count plot. So the male value is 157 here and female value is 87. so which is showing over here. This is female value, so this is count plot. Next, you can also have a box plot. So box plots are used to show the values, right? Interval values. So here I'm specifying the figure size, which is 9 by 6. So specifying the style dog grid, and I'm having a box plot SNS dot box plot of on x-axis showing the day, and y-axis is total bill, and this is the data frame name, and comparing this with the gender. And you're also adding a legend location is equals to best, means legend values are shown at the free space, so the library will decide where to add the legend. So you can see on which day more total bill. So on which day it is, I think it is shorted Sunday, right? And we have who have sent more, female or male. So male means blue color, female orange color. So you can check out more billing on Sunday, and females have paid more on Saturday, this one. And box plot represent these things. This is the minimum value, this is going to be maximum value, this is 25 percentile, this is 50 percentile, this is 75 percentile, this is maximum means 100 value. And these dots, the black dots, are called as outliers, means it has crossed the range. So you can go for outlier analysis to remove these values and make the data normal or standard. Then we have violin plot. So we have violin plot. So violin plot is the combination of box plot and KDE plot, kernel density estimation plot. So this is the predefined method, SNS dot violin plot, and x is equals to day and y equals to total bill, and data frame name we mentioned, and then comparing with gender, and split is equals to true. So split equals to true means you can have the comparison between the categorical values comparing each other. If you write split is equals to true, you can see male blue color, female is orange color, and these are shown separately. And this one is KDE plot. Okay, this one is KDE plot. So more billing is on Saturday by whom, male or female? So this is male, right? More is on female on this Saturday, right? So we can see the values also, numerical values also. Next is strip plot. So strip plots draws a scatter plot representing all the data points, and where one of the variable is categorical type, means string type. So specifying the figure size here. On x-axis you are showing day, y-axis total bill, data frame name mentioned, jitter equals to true. It means that it spreads the data points so that they are not stacked on top of each other. Understand, they are not stacked on top of each other. And comparing with gender, and dodge equals to true means it separates men and women data. So when you run this cell, you are going to see the output. So this is strip plot. So male females are separated, and no values are plotted on top of each other. So that is strip plot. Next, another plot is swarm plot. It is similar to strip plot, but the points are adjusted so they don't overlap. Okay, they don't overlap, and we can also say it's a combination of violin plot and strip plot. So this is the method used, swarm plot. X-axis value is day, y-axis is total bill, and having the graph between two variables. You can see the swarm plot, male female values, right? We have not compared here, so that's why day and total bills are shown here on each day, Thursday, Friday, Saturday, and Sunday. Then you can also do the comparison here. So violin plot we are having, and then on top of that having a swarm plot, and color equals to white for the second one. So when you are having both on top of violin plot, you are having the values, right? So this is the relationship between the two variables, day and total bill. Next, similar to the previous one, but comparing the values with the gender wise. So hue is equals to sex, gender splitting true, then you have the values of a male and female separated. So this is male, this is female. For more information you can take help. And color palettes, how to mention. So here I'm specifying the figure size, setting the style to dock, context to paper, context to talk, and then having a strip plot. So per color palette you changed here seismic. For more information you can refer the documentation of this to see what are the different color palettes available. So male and female values are separated here. Then matrix plot, the third category is matrix plot. Under this we have the heat map. So as you know, if you have the basics of matplotlib, so heat maps are used to show the relationship between the variables, right? You can have the relationship between the variable, and if there is a high correlation, then that is represented with the dark color. So you're having a color scale. So first of all you need to find the correlation. This CORR is a predefined method which gives the correlation between the two variables. So correlation could be positive or it could be negative, or sometimes no relation. Sometimes no relation. So depends on the relation, depends on the correlation value. You can have the no value represented, I mean correlation value represented in terms of graphs, sorry, in terms of colors. So SNS dot heat map, this is the data frame name. Annotation true means the values are also plotted, and color map with the style blues. So this is the heat map. So showing the relationship between the total, for example here total and incidence losses is negative correlation. That means if total value increases, incidence losses also decreases. And this one representing the higher correlation, dark blue color is higher correlation, and white one, so that is low correlation. So which variable has higher correlation here? So this is 85%, 83, 96. This one is higher. That means total and what is this column? No previous. No previous is having the higher correlation, 96%. Getting 96%. And then now we are also exploring one more data set, that is flights data, displaying the header part of that. And this data set has three columns: the year, month, and the number of passengers in the particular month. So it is also built-in data set. On this data set we want to have a correlation, so flights dot correlation, and having a heat map. Annotation equals to true means you can also have the values. So this one, year and passenger 0.92. If the variable is same, then 1 means 100%. So this color representing the higher correlation. And we can also segment this data, so by using the pivot table. So specifying the figure size here 8,6, then setting the paper context to paper, font scale 1.4, and first of all you are pivoting the data, splitting the data based on the index equals to month, column is year, and value is passengers. On top of this you are having a heat map. So by doing this, so the value is, data is splitted right on months. So this is year, on y-axis you have the month. So from this graph you can determine in which month the number of passengers are more. So as you can see, July, June, and August. So more in July. So basically this July is considered as a vacation type, break time. So during the break time the people will travel more, they'll go for vacation trip. Next another graph is cluster map. So I'm exploring the data set, that is iris, and displaying the header part of the data. So this is the target variable spaces. So if you are having the basic knowledge of machine learning, or if you have used iris dataset with matplotlib, then you might be having the basic knowledge on iris. So iris is a flower dataset. So based on the sepal length, sepal width, petal length, petal width, so you can determine the type of flower. So there are three types of flowers here: setosa, versicolor, and vozinica. And even as per the data set, so the shape of this data is 150 rows and 5 columns. and first 50 rows belongs to the flower type setosa, next 50 belongs to the flower type versicolor, and next 50 belongs to the flower type virginica. And we are also getting the value and then count here, iris dot species dot value count. So each category has 50 50 50 50, so total is 150. And from this iris data frame you are subtracting this, you are removing spaces, and the remaining part is assigned to the variable, sorry, the last column is accessed and assigned to the variable spaces, and then having a cluster map. So specifying the figure size here 8 comma 6, setting the paper context, and then having a cluster map on iris. So this will give us the uh, cluster map. So I have a video on doing the clustering. So this is called as dendrogram, right? This is called a dendrogram. So how the objects are grouped based on the similarity. So if you don't have the knowledge on this, so you can refer my video on clustering in the channel. So the variables which are having similarity are grouped together. So on y-axis you can see which variables are together. So this is heat cluster map. And next this is another example having a cluster map on the data frame flights. Color map is blue, standard scale is equals to 1. Standard scale means we are doing the data normalization. So you can see the month July and August are having more passengers. The values are more passengers, so that's why they are together. So this is a dendrogram, so which shows how the data is distributed or grouped. Next graph is pair grid. So pair grid means you can have the relationship between multiple variables. So I just summarize this over here, specifying the figure size, context, loading the iris data set, then having a pair grid on iris, comparing with the target variable, that is spaces, then having the scatter plot, plt dot scatter, and adding the legend also. So this shows the pair grid. So the output is going to be grid, as the name says, grid. Grid means rows by columns. So here we have 4 columns: sepal length, sepal width, petal width, and the relationship between the sepal length and petal width you can see, and these values are separated into 3 classes: setosa, versicolor, and virginica. So you can have a legend here. Setosa is blue color, versicolor is orange color, and virginica is green color. So this is the graph called as pair grid. Next you can also have a facet grid. So this is used for multivariate analysis. So this is quite bigger cell, so I just copied that in the next cell. So loading the data set, attention, and using the data using the function facet grid, and on this data frame attribution df, color is subject, color wrapping 5, and height is mentioned 1.5. You're having a map showing the values of 2 columns, solutions and score. So what is the relationship between the 2 variables, solutions and score? So you can see the relations, solutions, and the score. So how the value is increased or decreased. So this can be shown by using the facet grid graph. Next you can also have a regression plot. So loading the tips data frame again and displaying for the clarity, and then we are having a figure here, specifying the figure size, setting the context, then having the LM plot is used for linear regression plot. X-axis you're showing total bill, y-axis is tip, comparing these two with the gender. This is data frame, and you're also having the markers circle and cap, and specifying the keywords. The scatter plots attributes like S line width, edge color is wide. So when you run this, you are going to have a regression plot. So this is a regression plot. These values are separated into 2, that is males and females, and you can see the regression line, and male values are represented by using circle, and female values are just like triangle. So you can see the relationship between total bill and tip is positive. And this is another example having a same regression plot on two variables, total bill, tip, and comparing with day and gender, height mentioned, aspect ratio is also mentioned. So this is going to give us the relationship between the two variables, total bill and tip, and separating this data based on day. So you see total bill is more on Saturday by male, females or less. Got it. On Sunday you can also see total bill is more by the male, right? So this is a regression plot. So positive relationship between the variables total bill and tip. So that's it from today's session. So I have tried to explain what is Seaborn, how to import it, and what are the different categories. So we have seen the categories, like first is distribution plots, and next category is categorical, next is matrix, and with respect to these three categories we have seen the different kinds of graphs, right? So if you have any question, feel free to contact, or you can also comment. And if you don't have the basics of Seaborn, you can refer our other video, that is the tutorial on matplotlib. So that is prerequisite. And once you have gone through these two videos, then you can take any open data set, and by following the video tutorial of matplotlib and Seaborn, so I hope definitely you are going to have very attractive plots with the combination of matplotlib and Seaborn. So do subscribe our channel, stay connected for more updates.